Number 6, we're going to find the value of x such that it makes r parallel. And we're going to have to state the theorem. Well, we can say that these angles here can be congruent. So x can be equal to 2x. Oh, no, we don't. These are both on the inside. No, we want to do x plus 2x is equal to 180. This is the consecutive interior angles that states if they are parallel lines, then the two consecutive interior angles are add up to 180. But for us to show that it's parallel, we have to use the word converse. That allows us to set up this equation. Okay, x plus 2x is 3x. This equals to 180. Divide 3 to both sides. This cancels. X is equal to 60. Based on the converse of consecutive interior angles, if this is 60 and this is 120, then they are parallel. Okay. B, well, these looks like this is here and this is here. That is alternate exterior angles. So x is equal to 90 minus x. Based on the alternate exterior angles, we can only do this if it's parallel. So let's assume it's parallel by using the converse. But that states that if these two are congruent, then the lines are parallel. We can solve. So we're going to add x to both sides. This cancels. 2x is equal to 90. Then divide by 2, divide by 2. This cancels. We have x is equal to 45. Okay. So if x is 45, this is 45, and this is 45, then you can show that they're parallel, only because of the converse of alternate exterior angles. Next, these two are both on the inside, so that is interior, and they're crossing, so they're alternate. We are allowed to set up the equation 2x plus 20 is equal to 3x if they're parallel. We'll assume they're parallel by using the converse. So by the converse of the alternate interior angle theorem, these two angles are congruent. Minus 2x to both sides. This cancels. 20 is equal to x. There you go. We know that if we plug in x here, this becomes 60. If we plug in x here, this also becomes 60. And then we can show that they are parallel because of the converse of alternate interior angles.